Which function is a quadratic function? So recall that there are three main forms that we can write a quadratic function in. I'm going to kind of copy and paste from the other problem and just quickly explain. Bam. So the first form here is known as the standard form. Okay, ax squared plus bx plus c, where those a, b, and c's are constants. Everything in purple is going to be a constant. Anything in green on that other side, or teal, I don't know. The color's not really my thing, but you know, the greenish color is going to be a variable. So the first one is going to be the standard. The second one is the vertex form, all right, where I have a constant a multiplied by then some squared binomial x minus h plus then some constant k. Last but not least, I have factored form, where I can actually add to this. I'll add to this a leading coefficient of a, because there can be a leading coefficient there. Doesn't have to be, but I probably should just add that. All right, leading coefficient of a multiplied then by two binomials. Each of them are going to represent an x subtracted by or added to really some constant. All right, so we just want to be able to identify. All of these have slightly different meanings, but we're going to get to that in a later series of videos. Now, when I look at my answer choices, I'm trying to just match this up. All right, choice number one does look attractive. In the denominator of it, we do have a quadratic function, but that's the problem. It's in the denominator. Okay, when I have my quadratic standard form function over here, it is not under 1. Technically, it's over 1 if I wanted to kind of look at it that way as a fraction. So that's just out. That can't be. Now, you can also graph this. You can throw that into your calculator and see what you get. If you get, and it won't happen, but if you get something like this, something that looks like a smiley face, now the whole graph has to look like a smiley face, or a frown face, then you're dealing with a quadratic. But if you have a graph that looks like this, somewhat of a quadratic, and then in some component it goes up like this, and some component it goes down, or something crazy, that's not a quadratic. You have too many features. It has to have only this one feature. Okay? So hopefully that makes sense. So if you want to graph that, give it a go on your calculator and see what kind of graph you get. Second answer choice. Now the second answer choice, this most closely resembles which of the three forms? Right. I think it most closely resembles the vertex form. Now, we do have a binomial here, and we have a binomial in here, and we do have a binomial squared in our answer choice, and we do have a squared binomial in the vertex form. But the variable in the vertex form is to the first power. The variable here in our answer choice is to the second power. No good. No good. That's just not going to work. That's not a quadratic. Third, we now have an answer choice here that I would say most closely resembles the vertex form, right? 2 multiplied now by our squared binomial of x minus 1 plus some constant 3. That actually matches our vertex form perfectly. So I'm going to say that that's probably the answer. But last but not least, I just want to analyze the last part. The last choice here does look like factored form, right? It really does. I mean, it looks very close. But remember, everything I have in purple on the right-hand side is a number. It's a constant, not a variable. So the leading coefficient here of a must be a constant number. The leading coefficient in this, form is a variable. That's no good. That's not going to work. This is actually going to be a cubic function. All right, it'll have actually 3 roots. We'll get to that when we cover cubics. But that would not be a quadratic. Hey, you made it. We're at the end of question number 20. Of identifying quadratic functions. I'm really proud of you if you made it this far. Stay determined. Stay focused. All right, and now let's move on to the next subchapter. We're going to talk about the domain and range of quadratic functions. I'll see you over there.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.